Yes, my dear students of ninth standard, I welcome you all to learn a new lesson, Unit-11, Atomic Structure. Already we have discussed about 10th unit, that is matter around us. And matter around us, that you have learned about what is called matter. Matter is anything that has mass and occupies space. And also matter is classified based on physical state and chemical composition. Based on physical state, solid, liquid and gas. This already you have learned in 8th class, 8th standard. And the 9th standard you are learning about the chemical composition, the classification about chemical composition, that is pure substances and mixtures. And also we have discussed about the elements, compounds and differences between element and compounds, differences between mixture and compound, and types of mixture, whether it is a homogeneous mixture or heterogeneous mixture, and also different separation methods. We have learned sublimation, centrifugation, separating funnel method, distillation method, fractional distillation method, and chromatography, paper chromatography. All this we have learned. And also solution we learn what is called a solution. It is a homogeneous mixture of two or more substances. And solution also there are three types of solution based on the particle size: suspension, colloidal solution and true solution. And we learned about a special kind of colloid emulsion. Also you are instructed to write classwork for all the textbook exercises. You have to write in our classwork and maintain classwork neatly and prepare well. And my dear students, and next week you will have an objective test on Unit 10. Unit 10, the lesson that you know, that is matter around us. In that lesson, you have to write an objective test. And I will give the time and everything. I will send time and everything, time and date. You prepare all the textbook exercises, all the objectives you have to prepare well. And the 25 questions will be given. You can take the answer in your device itself, and the marks are going to be registered. So prepare well. Now we are going to discuss about atomic structures. Already we learned atom, which is a basic unit, a fundamental unit of all the matter. So matter is made up of atoms. So atoms only composed to give a matter. And see, in the introduction part it is given, see, just as a small child wants to take a toy apart to find out what is inside, scientists have for long been curious about the internal structure of an atom. So this curiosity of the scientist to learn about the internal structure of atom and what are the particle present inside the atom helped the scientists to propose various atomic models. Various atomic theories were proposed. And also you have learned Dalton atomic theory and J.J. Thomson atomic model in class 8. Whether you have remembered or not, but you have learned. Now we are going to learn about subatomic particles and other atomic models, and how the particles are arranged in the atom, how the electrons are arranged in the atom. All this we are going to learn. Before that, you have to remember what is Dalton's atomic theory. So Dalton atomic theory is nothing but that is the atom was indivisible and indestructible. So this you have learned, this Dalton atomic theory you have learned in standard 8. The atom was indivisible and indestructible. But this atom model was failed because of the discovery of the fundamental particles of electron and proton. Because of the discovery of the fundamental particle electron and proton inside the atom led to the failure of this aspect of Dalton's atomic theory. Then next to see J.J. Thomson model. So J.J. Thomson tried to explain different model of atom, and that he proposed model of atom that is more or less similar to a Christmas pudding, like a Christmas cake, how the fruits and nuts are embedded in the Christmas cake, like that. Also we can compare with think about watermelon. In the watermelon, see the positive charge in the atom is spread all over like the red edible part of the watermelon, and well, electrons are studded in the positively charged sphere like the seeds in the watermelon, like the seeds in the watermelon. This is the model of J.J. Thomson atomic model, and he proposed J.J. Thomson proposed an atom consists of a positively charged sphere and the electrons are embedded in it. And also J.J. Thomson proposed the negative and positive charges are equal in magnitude. So the atom as a whole is electrically neutral. The atom as a whole is electrically neutral because of the positive charge and the negative charge are equal in magnitude. So these things already have learned in 8th standard. So now we are moving to our portion, that is discovery of nucleus. See, in 1911, Lord Rutherford, a scientist from New Zealand, performed his famous experiment of bombarding a thin gold foil with a very small positively charged particles called alpha particles. See, alpha particles are nothing but doubly charged helium ions, and they have mass of 4 atomic mass unit. And also see, Rutherford selected gold foil for his experiment because he wanted as a thin layer as possible, and gold is a most highly malleable metal. Malleable means that can be converted into very thin sheet. See, metals are malleable, metals are ductile and malleable, that you have learned the properties of metal and non-metal. Metals are malleable, can be converted into thin sheet without breaking. Apart from that, gold is highly malleable, most malleable metal, that is gold foil was about 1,000 atoms thick. Gold foil was about 1,000 atoms thick. Such a small, very small layer can be obtained using gold foil. That's why he selected gold foil. And he bombarded the gold foil using alpha particle. Bombard means striking. He allowing the alpha particle to strike the gold foil, to hit the gold foil, And say alpha particles are doubly charged helium ions having mass 4 atomic mass units, so they possess some sort of energy. From this experiment, Rutherford observed most of the alpha particle passed straight through the foil. So most of the alpha particles are without any deflection or deviation and pass through the foil and straight away. And secondly, only some of the alpha particles were slightly deflected from their straight path. Very few, some particles deflected back, deflected by small angles, Then third point, very few, surprisingly, very few alpha particles completely bounced back. That is, 1 out of every 12,000. That is, 1 out of every 12,000 particle appeared in rebound. 1 out of every 12,000 particles appeared in rebound. These are the observations made by the gold foil experiment by Rutherford. And see, later Rutherford generalized these results of alpha particle scattering experiment and suggested model of atom that is known as Rutherford. So from this experiment, he suggests a model of atom. See, in the figure 11.2, it is given the experiment. This illustration explains the experiment of gold foil experiment striking by the alpha particle. See, the box is a lead box which contains radium source of alpha particle. Radium source of which is a radioactive material is there. See, which is going to radiate the alpha particle. I told alpha particles are nothing but helium ions, doubly charged helium ions. And here see, very small number of alpha particles significantly deflected, that is deflected by 180 degree angle, and a few alpha particles are slightly deflected, and most of the alpha particles are passed through the gold foil without any deflection. And around this illumination screen is kept to detect the scattered alpha particle, and he used very thin gold foil for this experiment. So from this experiment, he suggested model of atom that is called Rutherford atomic model. See, what is his suggestion? See, the atom contains large empty space. The atom contains large empty space. Why? Because most of the alpha particle passed through the gold foil without getting deflected. That is the reason most of the alpha particle passed through the gold foil without getting deflected. So from that only he observed atom contains large empty space. Second point, there is a positively charged mass at the center of the atom known as nucleus. So the center of the atom is highly concentrated and very small volume of part is there, that is called a nucleus, that is positively charged center, because only very few particles were deflected from their path. Only very few particles deflected from their path. So from that only he concluded this second point. Then the size of the nucleus of an atom is very small compared to the size of the atom, because very small fractions of alpha particles were deflected by 180 degree. Only one or two, only few particles only deflected back at 180 degree. From that he concluded the nucleus, the size of the nucleus is very, very small compared to the size of the atom. And fourth point, the electrons revolve around the nucleus in circular path called orbit. So orbit means what? The circular path in which electron revolve around the nucleus. The circular path in which electron revolve around the nucleus is called orbits. Also we use such different names, shells, energy levels. Then fifth point, an atom as a whole is electrically neutral. Atom as a whole is electrically neutral because of the presence of same number of protons and electrons. Protons, protons are positively charged particle and electrons are negatively charged particle. If same number of protons and electrons are, means that these positive charges are going to be neutralized by negatively charged particle. Ultimately, the atom as a whole is electrically neutral. So these are the few points he put as postulates for the model of atom. Then Rutherford's model of atomic structure is similar to the structure of solar system. See how in the solar system the sun is at the center. Sun is at the center. Planets revolve around the sun in definite circular path. Similarly, nucleus is at the center. Nucleus is at the center, which is a positively charged core, and electrons revolve around the nucleus. That's why it is similar to the structure of the solar system. Just as in solar system, the sun is at the center, planets revolve around it. Similarly, atom, the nucleus contain main mass, the electrons revolve around the orbits or shells. Then what are the limitations or drawback? So this model of the atom also failed. This model of the atom also failed. What is the reason? See, according to the electromagnetic theory, a moving electron should accelerate and continuously lose energy. Due to the loss of energy, path of electron may reduce and finally the electron should fall into the nucleus. If it happen, so atom become unstable, but the atoms are stable. The Rutherford model failed to explain the stability of atom. So the stability of the atom was not explained by Rutherford. So according to electromagnetic theory, when electron revolve continuously, it going to radiate energy, it going to accelerate the energy. When energy is lost, means what takes place? The electrons are going to be pulled by the nucleus. Electrons are pulled by the nucleus. So electrons going to merge with the nucleus. Electron merge with nucleus. If all the electrons are merged with nucleus, means that atom become unstable. Atom become unstable. But actually, naturally, atoms are in stable condition. But this was not explained by the Rutherford. The stability was not explained by the Rutherford. This is the drawback of the or limitation of the Rutherford model of atom. Then see, next model, Bohr's model of atom. Bohr's model. In 1913, Niels Bohr, a Danish physicist, explained the causes of the stability of the atom in different manner. See, the next scientist, Bohr, in 1913, explained the stability of the atom. Stability of the atom based on the different postulates. What are the postulates of Bohr's atomic model? See, in atom, the electron revolve around the nucleus in stationary circular path called orbits, shells, or energy level. See, the same idea, but here it is given. See, stationary circular path. That means what? That each circular path possesses a certain quantity of energy. We used to sell quantum energy. So each circular path possesses a quantum of energy. So that shell is called orbit or energy level. Then, while revolving around the nucleus in an orbit, electron neither loses nor gain energy. So, the electrons which is in a particular orbit will be in the same energy level, will have the same energy of that orbit, which will not be lost, So because of the revolution, the electrons will not lose or gain energy. Then third point, an electron in a shell can move to a higher or lower energy level by absorbing or releasing a fixed amount of energy. The movement of electron from higher level to lower level, level to higher level takes place only by absorbing or releasing a fixed amount of energy. Otherwise, the electrons will not going to lose energy, will not move from that orbit to any other orbit. Then Next point, the orbits or shells are represented by the letters K, L, M, N or the numbers N is equal to 1, 2, 3, 4. These are the numbers which are going to represent the orbits or shells. We used to tell energy level. Energy level, that N means energy level. N is energy level, that is first energy level 1, energy level 2, energy level 3, 4, like that. That K shell, you see the diagram 11.5, the nucleus is at the center, which is a highly positively charged core which possesses mass. The mass of the nucleus is completely based on the mass of the atom. So the mass of the atom is completely based on the nucleus, and which is a positively charged center. It is a positively charged center. The electrons only revolve around the nucleus, and these orbits, these circular paths are called orbits or shells, which are represented by K shell. K shell is the nearest shell to the nucleus. Next shell, L shell. Next M, then N, like that. So the orbit closest to the nucleus is K shell. It has the least amount of energy. Less energy is there in the K shell. So the electron present in it are K electrons, and so on with the successive shells and their electron. These orbits are associated with a fixed amount of energy. So Bohr called them as energy level. So we can also see say that orbit, shells are energy levels because each orbit is associated with certain amount of energy, certain amount of energy, fixed amount of energy. Then what are the limitations? So there are also some drawbacks. There are also some drawbacks, demerits, limitations of Bohr's model. One main limitation was that this model was applicable only to hydrogen and helium ions, like that. Only to hydrogen and hydrogen like ions like the helium, lithium, beryllium. It would not be extended to multi-electron nucleus. That is one of the drawback. So then what is the next one? See, discovery of neutron. In 1932, James Chadwick, you have to underline, the scientist James Chadwick only discovered the presence of neutron in the nucleus of an atom. He observed when beryllium was exposed to the alpha particle with about the same mass as proton were emitted. So, in 1932, James Chadwick observed when beryllium was exposed to alpha particle. He used beryllium. See, Rutherford used gold foil. James Chadwick used beryllium, and beryllium was bombarded by the alpha particles. What happens? See, particles with about the same mass of proton. Mass is same, but it not going to have the same charge of proton. Such a kind of particles were emitted. Same mass of proton, but not the same charge of proton. Such a kind of particle were emitted during the bombardment of alpha particle by beryllium. Then beryllium plus alpha particle gives a carbon plus a particle, kind of particle that he named as a neutron. Then let's see, these emitted particles carried no electrical charge. So the particle found by the James Chadwick was not carrying any charge, no charge, neutral particle. So they were called as neutrons, denoted by N01. That 0 means no charge. And see, the subscript 1 represent the mass having 1 but no charge 0. what are the properties of neutron? This particle was not found to be deflected by any magnetic or electric field, proving that it is electrically neutral. So he tested that James Chadwick tested this particle, whether what kind of charge is in the neutron. He allowed the particle to pass through a magnetic field, keeping two electrode, one is positive and negative electrode, allowing this particle to pass through this electric field and magnetic field, and these particles were not deflected towards the positive electrode or negative electrode, towards north or south. So proving that these particles are neutral particle, not having any charge. This particle carry no charge, no electrical charge. That's why these particles were passed through the magnetic field and electric field without any deflection or deviation. Then what is the mass of the neutron? The mass is equal to 1.676 in 10 power minus 24 gram. That is one atomic mass unit. Then see that, do you know, in 1920 Rutherford predicted the presence of another particle in the nucleus as neutral. So 1920 itself Rutherford prediction gave one more particle is in the nucleus. One more particle is in the nucleus, which may be a neutral particle. He predicted already, but after that only in 1932 only, the student of Rutherford, James Chadwick, was the student of Rutherford, invent the neutron, invent the presence of neutron. Then, what are the characteristics of fundamental particles? See, the atom is built up of a number of subatomic particles. The three subatomic particles of great importance in understanding the structure of atom are electron, proton, and neutron. So, not only these three particles in the atom, there are other particles also in the atom, but we are taking only these three particles because these three particles only going to give very great importance, mean that the charge of the atom, the mass of the atom, the stability of the atom, all these are based on these three particles. That's why we are going to consider the great importance of electron, proton, and neutron. And see, in table 11.1 the properties are illustrated. Electron, that is simple, -1 is 0, charge is a negative charge, and mass very negligible mass, that is 1 by 1837. Electron possess very negligible mass, that is 9.1 10 power minus 28. The proton 1h1 plus 1 unit positive charge is plus 1 and mass 1.6 10 power minus 24, one atomic mass in it. Similarly, neutron also possesses one atomic mass in it. The proton and neutron possess same similar kind of mass. That's why see, the total mass of the atom is embedded in the nucleus of an atom. That's why the nucleus is highly concentrated core of the atom. Nucleus is highly concentrated core of the atom because of the massive particle of proton and neutron. There are two structural parts of an atom, the nucleus and the empty space in which there are imaginary parts are called. So there are two parts of an atom. One is nucleus. Another one, the imaginary path, orbits or shells or energy levels. See, the nucleus is a highly concentrated core which possesses the proton and the neutron. Proton is positively charged particle, neutron is neutral particle. And in the imaginary path, electrons revolve around the nucleus. Electron revolve around the nucleus. Then the nucleus, the proton and neutrons are found in the nucleus of an atom. But I told the proton is positively charged, neutron is neutral particle, neutral particle. But actually these two particles are collectively called as nucleons. Proton and neutrons are collectively called as nucleons. What are nucleons? Question will be asked. Nucleons means the sum of proton and neutron present in the nucleus of an atom. The sum of proton and neutron present in the nucleus of an atom. That is called the nucleons. Then orbits. Orbit is nothing but it is defined as the path, the imaginary path by which electron revolve around the nucleus. Orbits or shells or energy levels are nothing but the imaginary path in which electron revolve around the nucleus. The circular path in which electron revolve around the nucleus. The definite orbit, the definite circular path in which electron revolve around the nucleus. So there are different formats are there, but you can pick out any one format which is easy for you and write. When you are asked to write, define orbit. That is the path in which electron revolve around the nucleus. Then see that, do you know, besides the fundamental particles like protons, electron and neutron, some more particles are also discovered in the nucleus. They include meson, neutrino, antineutrino, positrons, etc. Also some other particles are also there. So these particles are not playing very important vital role in the stability of the atom, the configuration, the chemical reaction and the mass structure. That's why we are not considering. We are considering the fundamental particle, the subatomic particle, proton, electron, neutron are the three fundamental particles of an atom. Then next part is atomic number and mass number. This we will discuss in the next class. So far we have discussed about this first one. See that we have discussed about Dalton's atomic theory, indivisible. Then J.J. Thomson already have learned in the 8th standard, discovery of nucleus by Lord Rutherford, and he bombarded the thin gold foil using the alpha particles. From that only he concluded that atom contain large empty space, positive nucleus, and size of the nucleus is very small compared to the size of the atom, and a circular path called orbit, and atom is electrically neutral. And also limitation is there because according to the electromagnetic theory, the loss of energy take place, but atom is stable. This was not explained by the Rutherford. This is the drawback of the Rutherford. So Bohr's explained the causes of stability of the atom, that Bohr told electron, when they are in the circular path, they will not lose or gain energy. This is the idea given by Bohr. Bohr told energy level or energy shells because each orbit is associated with a fixed amount of energy, and also there is a limitation because this model explain only hydrogen, helium, lithium, beryllium, like very simple atoms only can be explained. Then discovery of neutron by James Chadwick. He bombarded the beryllium using alpha particle. He collected a kind of particle that is chargeless particle neutron, and he proved that it contained no charge using the magnetic and electric field. And also the characteristics of fundamental particle. There are three important particles: proton, electron and neutron. And the imaginary path in which electron revolve around the nucleus is called orbit, and nucleus, which consists of proton and neutron, collectively they called as nucleons. The imaginary path, the circular path in which electron revolve around the nucleus is called orbit. So my dear students, you have to go through up to this, you have to revise up to this, take a note down in a notebook and prepare well, and you should always in the right path of this learning process. And next week, I already told, next week you will have a test, you will have objective test on the previous topic, that is unit 10, matter around us. 25 questions will be given. All should write. These marks are going to be registered. These marks are going to be registered, and don't be lazy and lethargic, and prepare well. Wish you all the best. God bless you. Thank you.